Welcome back to part 3 of our special AMC 8 series with Andi Guo, a great friend of MTC. In this video, Andi will be walking through questions 16 to 20 of the 2024 AMC 8, some of the toughest problems on the contest. We're super thankful to him for sharing his insights and love for problem solving with all of you. If you're also passionate about math and want to contribute a video of your own, we'd love to hear from you. Just send us a message at contact@mathtogether.ca. Let's dive into these final stretch questions together.
Min enters number 1 through 81 through the cells of 1 9 by 9 similar to calculate the parts numbers in each row and column. What is the least number of rows and columns that can have a product divisible by 3? So we can just consider which ones have 3. So we have like 3, 6, 9, 12, to 81. And we just want to pack how many are there first? 81 divided by 3 equals 27 different multiples of 7. And we want to pack them all as tight as possible into some small collection of rows and columns. So like sum R times C equals to 27. We want to minimize R plus C. So we're just going to find factors as close as possible to each other. That divided by 27. But 27 is just 3 to the power 3, right? So the factors that we can probably just find are just 3 times 9, and 3 plus 9 equals to 12. And, can we do better? 27, 1, 3, 9, 12. So we're just going to have a 3 by 9 column over here. We're going to be in total 9 plus 9. Actually, can we rearrange this slightly better? Yeah, we can. We just want to raise 27 to some opposite split. We can have it 4 and 8, 32. That contains 27. Is there 5 times 6 also contains 27. So if we have this equals 5, that equals 6, we can group the 27 into some subset of these 30 cells. And it just has some remaining space here. Can we do even better? No, 5 times 6 is already really close together, so that just gives us a max. So D will be our answer for problem 16. Can I not erase? Oh, it's here. Problem 17. A chessman is said to attack all squares one step away from it. For example, vertically or diagonally. They will just attack all the other squares like that. And the white king and black king are placed on different squares of a 3x3 grid so that they can't attack each other. Well, instead of counting how many ways that they can attack each other, it's probably easier to count how many ways that they can attack each other. So firstly, there are 9 times 8 number of ways to pick 2 different squares for the kings. 2 different squares, right? So 72 ways. And how many ways will they attack each other? Well, that's if one of the kings, or the white king, I should say, is placed on the middle square. And then now the black king has just 8 other options, so that's 8 bad options. And then there's a symmetric case for the black king being placed on mid, and the white king having 8 other options. And aside from those bad positions, right, they can be placed in these 2 adjacent squares over here. Or let's just say like some corner set of these squares. So any 2 placements of the kings into these corners would be considered bad. So we have 4 of these corners, right? And then 3 choose 2 ways of placing them into the corners. So 4 times 3 equals to 12. So 16 plus 12 equals to 28. 72 times 28 for the number of ways that they can be placed. Wait, is there something else? No, don't overlap with them. Oh wait, but there's also times 2. So no, it's 3 times 2 because they're distinguishable. So 4 times 2 times 2 is 24 actually. 24 plus 6 is 40. So 17 minus 40 is 32, which gives us E for prompt 17. In problem 18, uh, three concentric circles are centered at O have radius 1, 2, and 3. Points B and C lie on a larger circle, and the region between the two smaller circles is shaded. As is the portion bound by BOC, and these two portions are equal in area. And we want to find the measure of BOC. So the measure of BOC in degrees, or let's just call it S, right? Over 360 times pi, and then 3 squared minus x over 360 times pi 1 squared, which equals to 8 times x, well, 8 pi times x over 360 will just be the shaded portion in this region. And then we have 360 minus x over 360 times pi 2 squared minus 360 minus x over 360 times pi 1 squared. And that should be equal to 3 times 360 minus x over 360 equals 3 pi. And so we just add those together. We get, actually, yeah, sure, whatever. Pi x over, 45 plus 360 minus x times pi over 120 equals to 1 over 2 times the total area. Well, let's just clear this up after so we have a little bit of space. And then we'll just try to put these under one denominator, or like fraction, right? So, actually, yeah, why did I put them back? I'll just convert them back to base 360, 363 over here. So we got 8 pi x plus 1080 pi minus 3 pi x over 360, which equals to 5 pi x plus 1080 pi over 360 equal to 1 over 2 times pi and r3 squared equals to 9, or just equals to 9 pi over 2. And then so what we can do is just separate these by those 5 pi x pi x over 360 plus, well, equals to 9 pi over 2 minus 1080 pi over 360. And that'll just be equal to 3 pi actually. So 4.5 pi minus 3 pi equals to 1.5 pi versus 3 over 2 pi. And then we have that equal to 3 pi x over 360. Or wait, no, not that. Where did it go? 5 pi x over 360 equals to 3 over 2 pi. And we'll just have, now for this to be working, right? So 5 pi x must equal to 360 times 3 over 2, which equals to 100 times 3 equals to 540. So, well, it's just 5x equals to 540, and x is equals to 108. Well, basically, that A is our answer. And assuming we didn't write anything wrong. Wait, is this true? No, that's definitely fine. This is pi here, pi here. I mean, I found out the multiple choice, so I think that's correct. Alright, problem 19 now. So, Jordan owns 15 pairs of sneakers. 3/5 are red and 2/5 are white. 2/3 of the pair are high top and the rest are low top. The red high top sneakers make up a fraction of this collection. What's the least possible value of this fraction? So 3 over 5 are red, and then 2 over 5 are white, but 2 over 3 are high top, 1 over 3 are low top. So we want to just shove as many reds as we can into this low top fraction, right? So that'll just give us the least amount of x into the high top fraction. And the remaining amount will just be 5 over 3 minus 1 over 3, which equals to just convert it to base 15. So times 3.9 over 50 minus 5 over 50. And that gives us 4 over 15 remaining. And that will be our answer for problem 19. Okay, that's fine. Problem 20. Actually, no, I'm pretty sure I'm done here. So yeah, that's it. And also problem 20. This is the last one for this video. Just copy and paste it. So this is just a standard find the equilateral triangles within the cube. Well, first you can just see that this length over here, this length over here, this length over here, we can call this 1, we can call this square root of 2, and we can call this which is square root of 3. So the reason why this one's just square root of 2 is because there's a 1 here, 1 squared plus 1 squared square root is just equal to square root of 2, and this thing over here is just square root of 2 squared plus 1 squared equals to 3, and then we take the square root of that, and that just equals to square root of 3. Now, if we use this one, right, there's going to be no other triangle that will help us satisfy that. So if we immediately take one out of consideration, for this one, no matter if we choose 2 ones, right, the third edge connecting them will just be square root of 2, and it won't be equilateral. So the only choice that we have is just to use the square root of 2 length diagonals. And we can form this, this, this. So that's just one possibility, for example. So for P, right, we can either choose to connect it to B, to T, or to R. So now we just choose 3, choose 2, any of these 3 work. And that just equals to 3 possibilities, and that gives us B.
That's a wrap on part 3. Great job sticking with us through questions 16 to 20 of the 2024 AMC 8. Big thanks again to Andy for walking us through these challenging problems and sharing his strategies. But we're not done yet. Stay tuned because in our next video, James will be taking over to solve the final stretch, questions 21 to 25. You don't want to miss that. And if you'd like to contribute your own problem-solving video, we'd love to feature you. Just shoot us a message at contact@mathtogether.ca. Thanks for watching, and let's keep exploring math.